Let's now look at the relationship between a force, a charge, and a uniform electric field. Um, the force applied to a charge that is in an electric field is F is QE. So make sure your uniform electric field is in newtons per coulombs. Your charge is in coulombs, not microcoulombs. And the force, of course, is in newtons. So now a diagram for these is very straightforward. You're always going to have, we tend to make our electric fields like this. All right. And then we usually have a positive charge. So it's going to have a force going in the same direction. Now, if I were to have a negative charge, okay, a negative charge always has the opposite force direction. Now, sketch the electric field lines around the following scenarios. All right, a negative charge, so I'm going to put a negative Q. Now, remember, they're radially. It always starts on positive, ends on negative. So you want to make something that looks kind of like this. Make yours straight. Now, what about a 3.4 times 10 to the negative 6 charge? Okay, basically all I'm asking you to do is it's a positive charge. And a positive charge has the same shape as a negative charge, only these are all radially outward. Remember, it's away always from positive to negative, so it has to point away from the positive and toward the negative. Now, a 1C and a negative 2C, these two, let's see, this is 1 is positive, negative 2C. All right, this one's got to have twice as many charges. It goes from positive to negative. All right, so I'm going to do this right here. Positive to negative. All right, now that's pretty close. Now, this one has 1, 2, 3, 4, 5, 6. So I need to add 6 more. 1, they just kind of come in from wherever. 1, 2, 3, 4, 5. Okay, this one has to have twice as many as this one because the charge is twice as strong. Remember, these are just representatives. All right, what if I have a positive and a negative 1 coulomb, and these are, um, this is a dipole. Okay, a dipole is really cool. It always starts on positive, ends on negative. All right, and then it starts to curve. You always need this one right here that's straight. All right, and after that, they sort of curve around. Now let's pull a couple in here, like that. Kind of cool looking. What is the magnitude of the electric field? Remember, magnitude just means I want the number E, where a positive charge, Q, experiences a force of 0.7 newtons. So let's see, I have a charge of 5 times 10 to the negative 6 coulombs, and the force is 0.7 newtons. All right, I know I'm looking for E, the electric field. Now my equation, F equals QE. So I want E, so I'm going to divide both sides through by Q. So the electric field is going to be the force divided by the charge. The force is, let's see, 0.7 newtons divided by a charge of 5 times 10 to the negative 6 coulombs. And I get 1.4 times 10 to the 4th newtons per coulomb. The magnitude of an electric field, all right, now let's identify these up in here. This is E, newtons per coulomb. The force is 0.9 newtons, so this is F. How many coulombs does a positive charge have? So we're looking for Q. So my givens are I have E is 4.2 times 10 to the second newtons per coulomb. F is 0.9 newtons. I'm looking for Q. All right, F is QE. I want Q, so I divide both sides through by E. So Q is F divided by E. They look the same, don't they? So F is 0.9 newtons, and E is 4.2 times 10 to the 2. So zero point 0.9 divided by 420 is 0.00214 coulombs. There's our answer. Now, I have an oil drop that weighs 1.9 times 10 to the negative 15 newtons. It's suspended in an electric field with an intensity of 6 times 10 to the third newtons per coulomb. What's the charge? Let's draw a free body diagram. We have Fg going down. That's what this is. It weighs. So this is the weight. And now there's got to be an electrostatic force going up. So we're looking for the charge. So the Fe has to equal Fg. This is what we're doing here. So the weight is 1.9 times 10 to the negative 15 newtons. You have an electric field of 6 times 10 to the third newtons per coulomb. And we want the charge. Let's see how we can do this. I'm looking for Q. Now the trick is, because it's being balanced, I know Fe equals Fg, so this has also got to equal Fe. So I know Fe is QE. So the charge has got to equal the electric force divided by the electric field. So this is 1.9 times 10 to the negative 15 newtons divided by an electric field of 6.0 times 10 to the third, or 3.17 times 10 to the negative 19 coulombs. Now, I have a test charge that has a force of 1.4 times 10 to the negative 18 newtons, where E is 2. What's the test charge? All right, F is 1.4 times 10 to the negative 8 newtons, and my electric field is 2 times 10 to the negative 4 newtons per coulomb. I'm looking for Q. I know the force is QE, so the charge has got to be the force divided by the electric field. So Q is 1.4 times 10 to the negative 8 divided by 2 times 10 to the negative 4, or 7 times 10 to the negative 5th coulombs. Now, assuming the field is created by a negative charge, what's the direction of the field on the test charge? Toward the center of the field, away from the center of the field. Okay, let's look at it. A test charge. All right, here's my test charge. All right, or excuse me, here's my charge. Let's try this. Here's my test charge, okay? Right here. TC is my test charge. At a point where the electric field intensity is this. All right, if the field's created by a negative charge, so it's right here, what's the direction of the field? You see, for a negative charge, it is going to pull it toward the center of the field because my test charge is always positive. If it were a positive charge, and I'm going to do this one in red, it would be pushing it away. So the answer for this one is it's toward the center of the field because my test charge is always positive. Now, I have an electron, or accelerated by an electric field. Find the force. Let's see. I know Q is negative 1.6 times 10 to the negative 19 coulombs. And I know the electric field is 1 times 10 to the 5th newtons per coulomb. So the force is QE. So this is 1.6 times 10 to the negative 19 coulombs times 1 times 10 to the 5th newtons per coulomb. So this is 1.6 times 10 to the negative 14 newtons. Now, the sign, be careful with the signs, all right? Because if my electric field is going this way, all the negative means is my negative charge will have a force going to the left. So the electric field is produced by a positive charge. What's the direction of the electric field on the electron? Well, it's back. So opposite direction. How about that?